What if the seas we know today are only the upper edge of something much larger? A gentle line drawn across a map that once stretched farther out, covering plains and valleys now hidden beneath water? To hold this thought, we need to slow down and place ourselves in the scale of thousands of years, where time moves differently, where coastlines do not stand still, but breathe in and out with the rhythm of ice and warmth. During the last great cold period, much of the planet's water was locked away in immense glaciers, vast frozen bodies of snow compressed into solid ice, spread like blankets across continents. These glaciers were not fixed statues, but slow rivers of ice, moving almost invisibly, reshaping valleys and mountains, and above all storing water that would one day return to the sea. When the ice began to melt, the balance shifted. Imagine pouring water into a bowl, not all at once, but drip by drip, year by year. The oceans rose in this way, silently, steadily. A few centimeters over a lifetime may pass unnoticed, but across centuries and millennia the difference grows until whole landscapes sink below the horizon. Plains where animals grazed, forests where people walked, river mouths that once reached far into the distance, all gradually claimed by the sea. It did not happen in a sudden rush for most regions, but in a pace just slow enough to let each generation adjust, while the larger picture kept changing. Now let us linger a moment on how this process works. When ice melts, it adds water to the ocean. But the Earth's crust is not rigid. It bends under weight like a cushion pressed down. As glaciers grew, they pressed the land beneath them. When they melted, the land began to rise back again. This rebound and sinking, what scientists call isostatic adjustment, means that the story of coastlines is not simply about water levels. Some places sank faster than the seas rose. Others lifted themselves up from the burden of ice, and so the shore shifted in complex ways. We should admit here what we cannot fully know. The details of exactly which field or forest disappeared first are often lost, blurred by the passing of time and the restless nature of water. The sea erases as much as it records. Wood rots, soil washes away, stones tumble. Yet fragments survive, and from these fragments we build careful pictures. Sediments on the seabed hold grains of ancient rivers, showing us where fresh water once carved its way. Fossil corals mark the height of seas in different ages, since corals grow only in certain depths of sunlight. Old tree stumps, found beneath modern tides, tell us forests once stood where waves now move. Each of these is a marker, a quiet signal from the past, like faint handwriting on a page softened with age. We might try a small thought experiment. Imagine walking from today's shoreline straight ahead into the sea, as if the water were not there. Step by step, the land unfolds. At first sand continues, then marshy ground, then meadows with small rivers crossing them. Further out, we might see patches of forest, or the curves of hills now hidden. All of this once existed. The fact that it is invisible today does not erase it from history. If we imagine standing there as the water slowly returns, we would feel it rising not as a sudden wall, but as a persistent neighbor, returning each year, edging a little closer. Generations would build homes further back. Fields would be abandoned, but life would adapt, never in panic, simply in movement. What remains with us is a sense of scale and patience. Sea level rise is not an event in human time, but a rhythm in planetary time. And the drowned coastlines remind us that what seems permanent is only temporary. Our maps are not final, only chapters in a longer story written by ice and water. Perhaps that is the quiet lesson, to accept the openness of the horizon, knowing that beneath the calm surface lie many forgotten landscapes, not gone, only hidden, waiting as part of the Earth's deep memory. What if we imagine ice not as something static and cold, but as a slow, patient force that holds the memory of entire ages within it? Vast sheets of ice once covered much of the northern world, stretching across continents like immense blankets, pressing down on the land beneath them. In these frozen expanses, snow fell and compacted, layer upon layer, until it became solid ice, locked in place for thousands of years. Each winter added a thin veil, each summer sometimes removed a little, and across centuries the balance shifted, always gently, always with time. These glaciers are not rigid statues, but rivers that move so slowly we cannot notice their flow in a single lifetime. They slide under their own weight, carving valleys, smoothing rock, and carrying with them dust, stones, even traces of the atmosphere itself, sealed within bubbles of frozen air. To picture this, we might think of honey spreading across a plate, flowing so gradually it seems still, yet over hours it changes shape. Ice works in a similar rhythm, only stretched across millennia. When the climate warms, glaciers retreat, releasing water they have held for ages. When the climate cools, they grow again, capturing moisture from the air and expanding outward. Now, let us pause here, for these movements are not uniform. Not every glacier responds at the same speed. Some retreat quickly, others remain stable for long periods. There are gaps in our understanding because much of the evidence is hidden deep within the ice itself or has already melted away. The record is patchy, and scientists must piece together fragments. By drilling cores into the ice, long cylinders drawn from the frozen ground, researchers uncover layers like the pages of a book. Each layer contains dust, trapped gases, and tiny isotopes that tell us about the temperature and atmosphere at the time the snow first fell. It is not a perfect record, but it is one of the clearest archives we have. Now, before we move on, let us note that these ice layers do not speak with absolute precision. They can be disturbed by melting, shifting, or refreezing. So we treat them not as strict measurements, but as guiding signals. The language of ice is soft, not sharp, and it requires careful listening. Still, the patterns we read are clear enough. There have been cycles of cold and warmth, of expansion and retreat. Each cycle has reshaped coastlines, creating new maps and erasing old ones. We may try a gentle thought experiment. Imagine standing on a plain where today there is a glacier. At first, the land is covered in white, silent and vast. Centuries pass and the ice begins to melt. Streams form at its edges, carving small channels that grow into rivers. These rivers carry water back to the ocean, little by little until the sea rises. Now imagine the opposite. The world cools again, snow deepens, the rivers freeze, and the ice advances once more, covering the same plain. The shoreline retreats, and what was once ocean becomes land again. In this way, ice acts like a quiet breath, expanding and contracting, pushing the balance of land and sea back and forth across the ages. What is left behind when ice moves is also a kind of record. We see striations carved into rock, long grooves that show the direction of movement. We find boulders dropped in places where no mountain is nearby, carried there by ice and left when it melted. We observe entire valleys shaped into smooth U-forms, unlike the sharp V-shapes cut by rivers. These are signatures of glaciers, reminders that the land itself has been shaped by frozen rivers that passed long before. From all of this, we learn not to think of ice as absence, but as presence. It holds water. It holds memory. It holds weight that presses on the land and then releases it. It is both a record and a force. And yet we must acknowledge again what remains hidden. Not every glacier's past can be traced. Not every layer can be read clearly. The further back we look, the fainter the signal becomes until it merges into silence. Even so, the traces we do have are enough to show us that the story of ice is inseparable from the story of our coasts. Without ice, our coasts would be different. The nature of land and sea shifted by its movement and absence. Let us hold this in our minds, not as a hard fact, but as a quiet truth. It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. Understanding the patience of ice, we cannot understand why seas have risen and lands have sunk. Perhaps the softest conclusion we can draw is that ice, though it seems lifeless, has been one of the most active shapers of our world, holding the waters that would one day return to the ocean, guiding the shifting edges of continents, and leaving us with the knowledge that nothing we stand upon is fixed forever. What if the ocean we see today is only the most recent version of itself, a surface that has quietly climbed higher and higher as ice released its stored water? In the scale of human lifetimes, the change was almost invisible, yet across centuries and millennia, the difference was profound. Imagine a shoreline as a line drawn on the sand, and each century the tide comes just a little further in. At first only a few steps, then more, until entire valleys and plains are gone. The rise of the seas after the great ice sheets began to melt was slow in its rhythm, but steady in its reach. We find ourselves now in a moment that remembers those ancient movements, but to see them clearly, we must stretch our sense of time far beyond generations. The mechanism is simple to describe, though complex to measure. Ice, when it melts, turns to water, and that water must find its way back to the oceans. Each fragment of glacier, each mountain of frozen snow was a reservoir. As temperatures warmed, these reservoirs broke open, not in a single rush, but in a constant dripping.
Over thousands of years, this steady flow added volume to the seas. Scientists estimate that during the transition from the last great glacial period to the warmer age we live in now, sea levels rose by more than 100 meters. Spread across millennia, this means a few millimeters each year, small enough to pass unnoticed, yet unstoppable in its accumulation. Now let us pause to admit the limits of our certainty. We do not know the exact pace in every region. Some places recorded faster surges, others slower adjustments. There are signs of sudden pulses of water, perhaps when ice dams collapsed or when vast shelves of frozen land broke into the sea. But the evidence is fragmentary. Sediments, corals, and isotope records give us hints, not perfect clarity. We read patterns, but we know the ocean is too vast and the past too distant for complete precision. What remains reliable is the general story. The seas rose, and in doing so, they redrew the map of the world. The language of these changes is written in many archives. Coral reefs show us staircases of growth, climbing upwards as the water climbed. Ancient beaches, now drowned far below the surface, reveal lines where waves once broke. River valleys, carved deep into the land, now stretch far underwater, their shapes mapped by sonar and studied like ghost landscapes. Even cave systems bear traces, with stalactites cut off at odd levels where salt water once intruded. These are indirect signs, but together they compose a memory that the oceans themselves cannot speak. We can try a gentle thought experiment. Let us imagine a family living on a fertile plain near the sea. In their lifetime, the difference is barely visible. Perhaps a field lost to marsh, a river mouth creeping inward. But their children notice that the old path to the shore now crosses water. Their grandchildren speak of a forest that once stood where fish are now caught. Generations pass, and the shoreline that seemed stable has retreated by many kilometers. From the perspective of the sea, it was only a small rise, a few meters spread across centuries. From the perspective of people, it was a landscape transformed. Now we may linger for a moment on what this means for our sense of permanence. Maps show borders, coasts, harbors, as if fixed in place. Yet the rise of oceans teaches us that these lines are temporary. They belong to an age, not to eternity. What was once farmland is now seabed. What was once coastline is now buried under waves. We cannot walk those lands anymore, but their traces. It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. Remain in the quiet archives of geology and memory. The cautious conclusion we can draw is not one of loss, but of rhythm. The ocean is patient. It rises and falls with the cycles of climate, with the growth and retreat of ice. Human eyes see only a fragment of this long process. By listening to the signals left behind, in corals, sediments, drowned forests, we can sense the scale, even if we cannot reconstruct every detail. And in this soft recognition, we find a reminder that the edges of the world are never final, only passing moments in the larger story of water and time. What if the ground beneath the sea could speak to us, telling stories of rivers that no longer flow and plains that no longer breathe air? In many ways it does, through sediments quietly layered over time. These layers are like pages in an unwritten book, where each grain of sand, each speck of silt, carries a trace of what once was. To enter this archive, we must stretch our attention to scales far beyond a human life, for sediments settle slowly, almost invisibly, and yet across centuries they build records thicker than mountains of paper. The seabed is not empty. It is a vast library where water and gravity act as scribes. Every flood, every storm, every river mouth leaves its signature. Tiny shells of plankton fall, dust from deserts drifts across oceans. Volcanic ash rains down and settles into layers. Over time, these deposits press together, forming a sequence that holds memories of climate, currents, and even life on vanished coasts. Scientists call this stratigraphy, the study of layered rocks and sediments, but we might think of it more simply as time arranged in sheets one upon another. Now let us pause and consider the limits of what we can read. Sediments can shift, be eroded, or disturbed by currents. Some chapters in this underwater book are missing, some blurred beyond recognition. We cannot expect a continuous story. Instead, we have fragments, sections that align, gaps that must be filled with careful inference. Absence of a layer does not prove that nothing happened. It only tells us that the record was disturbed or lost. This is why we approach sediments with humility, listening for patterns but never claiming certainty beyond what the evidence allows. Still, there is a language here we can learn. For example, pollen grains preserved in seabed mud can reveal what plants once grew on lands now drowned. A shift from forest pollen to grass pollen might mark a change in climate or the gradual flooding of a plain. Similarly, the size of sand grains can tell us about the strength of currents or waves that carried them. Finer particles suggest calm, deeper water. Coarser grains speak of shallows or strong flows. Even isotopes, the tiny variations in oxygen atoms within shells, act as thermometers, showing whether the water was warm or cold when those organisms lived. Each marker is indirect, but together they weave a quiet tapestry. Now let us try a small thought experiment. Imagine walking across a wide coastal plain, dotted with trees and rivers. As centuries pass, the sea slowly rises, and the rivers retreat inland. The plain becomes a marsh, then a shallow lagoon, then finally a seafloor. Each stage leaves behind a layer. At the bottom, we would find river sands. Above them, marsh peat. Above that, fine mud rich with shells. And finally, marine clays. If we drilled down through those layers today, we could read this history in reverse, peeling back time grain by grain. It is a gentle reminder that the Earth records not just events, but transitions, slow changes written in material form. Before moving further, we should note that sediments also carry surprises. Sometimes a storm or flood deposits a sudden thick bed, interrupting the slow rhythm. Sometimes a landslide under the sea erases entire chapters. These irregularities make interpretation challenging. Yet they also remind us that the Earth's processes are both steady and abrupt, both gradual and punctuated. Reading sediments is like listening to a faint melody, where the notes occasionally
speak slowly, with soft pauses between sentences to create a comfortable and peaceful atmosphere. What once was land is now seabed, but the sediments keep the imprint. Perhaps the cautious conclusion is that the earth does not forget easily. It writes slowly, in a language of grains and layers, and although we may never translate every word, we can still sense the presence of those vanished landscapes, softly preserved beneath the waves. What if stone itself could act as a witness, holding quiet memories of where waves once broke and where coastlines once rested? Unlike wood or soil, stone endures. It weathers slowly, keeping marks and shapes long after the events that formed them have passed. When we look closely at cliffs, caves, or terraces, we find signals that water once moved differently, that seas once stood at another height. In this way, rock becomes an archive, not in words, but in scars and surfaces. On long time scales, waves carve at shorelines with patient repetition. Each day, tides wash in and out, grinding small fragments. Each year, storms arrive, cutting deeper. Over centuries, the sea wears platforms at the base of coasts. These are called wave-cut terraces, flat shelves of stone that were once the very edge of land. Today, many such terraces lie far beneath the surface, submerged by later rises in sea level. They are steps in stone, reminding us where the ocean once lingered. Sometimes we find caves, hollowed by waves when the water stood higher. Now these caves sit below tides, entered only by divers. They are chambers of memory, carved not by hands, but by the slow rhythm of water and time. Yet we must acknowledge limits. Not every hollow in stone was made by waves. Not every flat surface is proof of an ancient shoreline. Rock can fracture, rivers can cut, landslides can shape walls. Absence of certainty does not mean absence of history, but it means we tread carefully, always cross-checking one clue with another. This is why geologists compare shapes, materials, and positions before calling a structure a drowned shoreline. The language of stone is subtle, and we must learn to listen with patience. Now we may linger a moment on indirect signals. Fossilized shells embedded high in cliffs can show that the sea once reached further inland. Chemical traces in stalactites of coastal caves reveal when salt water touched them. Even microscopic scratches on boulders tell us of waves shifting them back and forth long ago. These are not loud declarations, but faint signatures. Each one is like a whisper, and only when gathered together do they form a clear story. Let us imagine, slowly, how this unfolds. Picture a coastline as it is today. Waves strike at its base, carving a notch. Over centuries, the cliff weakens and collapses, leaving a flat platform. The sea holds here for a long time, polishing the stone. Then the waters rise again, moving higher, beginning the process once more. After thousands of years, the cliff holds a sequence of terraces, each marking a pause in the ocean's climb. If we could drain the sea for a moment, we would see a staircase of platforms stretching outward, each step a record of a former sea level. Now we can shift the thought slightly. Imagine standing on such a platform when it was dry land. To one side, the waves crash at the cliff. To the other, fields or forests stretch inland. For the people or animals living there, this was simply the edge of their world. They did not know it would one day lie beneath meters of water. And yet, here it is, preserved, quietly, waiting. These traces teach us humility. Rock holds memory across scales far greater than our own. We can measure, map, and interpret, but we cannot claim absolute precision about every mark. Some records are lost to erosion, others hidden too deep to reach. What we know is partial. What we infer is careful. What we imagine must remain.
Still, the overall picture is steady. Stone witnesses tell us that seas have not always been where they are now, that shorelines shift with the patience of centuries. By reading their marks, we gain not final answers, but a sense of continuity, a reminder that landscapes breathe, and that even the hardest cliffs carry memories of change. Perhaps the gentle lesson is that the solid ground we trust is also part of the ocean's rhythm, a surface shaped, erased, and reshaped, its testimony written in terraces, caves, and scars. It is not a dramatic story, but a quiet one, unfolding across deep time, leaving behind traces for us to notice only if we take the time to pause. What if the rivers we know today once reached much farther, flowing through valleys that are now drowned beneath the sea? During the great cold ages, when much of the world's water was stored in glaciers, sea levels were lower, and rivers stretched far beyond their present mouths. They carved deep channels, broad floodplains, and winding deltas on land that no longer exists above the surface. To imagine this, we might picture the Nile or the Mississippi continuing their courses hundreds of kilometers further, cutting across plains that are now hidden by waves. When the ice melted and the oceans rose, these valleys were slowly filled, first with brackish water, then with salt, until they became estuaries and eventually sea floors. We now walk the edges of rivers that once traveled longer journeys, unaware that their lost paths remain quietly buried. Let us pause for a moment on the mechanisms that shaped this. A river always flows toward the lowest point, pulled by gravity. In colder ages, when seas were lower, the base level, what geologists call the point where a river meets the sea, lay much deeper than today. Rivers adjusted by cutting their channels downward, eroding stone, and carrying sediment far out across the plains. As sea levels rose again, the base level shifted upward, and rivers responded by slowing, by depositing instead of carving. Valleys once carved in depth were gradually drowned, their shapes softened by mud and tides. This process is natural, rhythmic, and long. Yet we must acknowledge our limits. Much of the evidence lies underwater, hard to study and easy to misread. Sonar mapping shows us ghostly outlines of valleys beneath the continental shelves, but details remain uncertain. Some features may belong to ancient rivers, others to landslides or tectonic shifts. Absence of certainty does not mean absence of history. We tread with caution, assembling indirect signs, knowing that some chapters are lost forever. The language of these drowned rivers still speaks in sediments. Core samples taken from seabeds reveal alternating layers, coarse sands from rushing fresh water, finer silts from calmer estuary waters, and marine clays from the open sea. In this order, we can trace the transformation of a valley into an estuary,
then into a seabed. Isotopes in shells show changes in salinity, marking the gradual entry of the ocean. Even pollen grains trapped in mud tell us what plants once grew along the banks before they disappeared beneath the tides. Each signal is faint, but together they show a story of retreat and replacement. Now let us try a gentle thought experiment. Imagine a river flowing freely across a wide plain. Step 1. It cuts its path, building fertile soil along its banks, and people or animals settle near its waters. Step 2. The sea begins to rise, creeping into the valley, turning fresh channels into brackish lagoons. Fields give way to marsh, villages shift inland. Step 3. The valley is fully drowned, the river now ending in a broad estuary filled with tides, and finally in an open gulf. In each stage, the river continues, always adapting, but its shape and course are altered forever. If we picture this across centuries, the quiet persistence of water becomes clear. The cautious conclusion is that rivers are both constant and changing. They follow gravity, they carve, they deposit, and they...
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. Their drowned valleys remind us that landscapes are not fixed, that what seems permanent can slowly vanish without drama, replaced by new forms. Today's coasts carry only the final strokes of much longer drawings. Beneath the waves, old riverbeds sleep, holding their silent records, showing us that the edges of land are always in conversation with the ocean, always moving in a dialogue written in silt and stone. What if forests once stretched where the sea now moves, their roots anchored in soils that are hidden beneath waves? Along many coasts, especially in shallow bays, storms sometimes uncover remnants of these forests. Darkened tree stumps, still upright, preserved in peat beneath layers of sand. They are fragments of landscapes drowned thousands of years ago, revealed only for brief moments before tides cover them again. These drowned forests remind us that what is now ocean floor was once dry land, filled with life and growth. In the long view of time, they are gentle markers of transition, places where land slowly gave way to water. To understand this, we can think of peat. Peat is a dense layer of partially decayed plant matter, formed in wetlands where water slows down decomposition. When sea levels were lower, large areas of peatland developed along river mouths and coasts. As the ocean rose, these wetlands were gradually submerged. The trees that grew there died, but their remains sank into the protective peat, which shielded them from decay. Over thousands of years, layers of mud and sand sealed these forests, locking them away until unusual tides or storms uncovered them once more. Now we may pause to reflect on what we do not know. The exact size of these drowned forests or how far they stretched is difficult to measure. Many are fragmented, exposed only in small patches. Some may never be revealed again, lying too deep beneath sediments. Their presence is undeniable, but their full story remains partly hidden. This uncertainty teaches us caution. We do not claim complete maps, only glimpses through the narrow windows that storms or erosion allow.
Still, these glimpses carry meaning. When scientists analyze the wood, pollen, and soils of drowned forests, they find signals of ancient environments. Pollen grains tell which species grew there: oak, pine, alder, or grasses. Isotopes in the wood reveal the climate at the time: wetter or drier, warmer or cooler. Even the spacing of the stumps suggests the density of the forest. In this way, the drowned forests become quiet archives, offering not just scenery, but data about the Earth's past. Let us try a simple thought experiment. Imagine walking through a low coastal woodland. The ground is damp, covered in moss and reeds. In the distance, a river winds toward the horizon. Step 1. The sea begins to rise, slowly, almost imperceptibly. Marsh grasses spread, trees weaken, and salt touches their roots. Step 2. The water deepens, the forest drowns, trunks fall, but the peat holds their bases like memory. Step 3. Centuries pass, and the sea lies fully above, waves covering what once was woodland. Then, much later, a storm uncovers the stumps again, giving us a glimpse into this ancient cycle. In this vision, we sense the patience of time. Before moving further, let us note something important. These forests do not suggest sudden catastrophe. Their drowning was not a moment of violence, but a process stretched across generations. People who lived nearby may have seen marshes expanding, may have moved gradually inland. The change was real, but it was slow enough to be part of life's adjustments. This difference matters because it reminds us that the story of drowned landscapes is not always one of loss, but of transformation. The cautious conclusion we can draw is that drowned forests are both records and reminders. They show us that the boundary between land and sea is not fixed, that what we see as permanent is only temporary in longer rhythms. Their silent trunks.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. What if the wide, shallow seas that border our continents are not seas at all, but quiet reminders of lands that once lay open to air and light? These continental shelves, stretching outward from every coast, are like hidden plains, now drowned but once alive with rivers, forests, and movement. Today they appear as shallow zones beneath the ocean, places where sunlight still penetrates, where tides stir sediments, where marine life gathers. Yet in the longer rhythm of time, they are stage floors where the sea and land take turns, advancing and retreating. To sense their scale, we can imagine the shelves as vast platforms surrounding each continent, sloping gently until they drop into the deep ocean. When ice ages locked water into glaciers, sea levels fell, and these shelves were exposed. They became enormous lowlands, connecting islands, widening coasts, expanding continents far beyond their current outlines. Animals moved freely across them, and humans may have followed. When the seas returned, these plains were drowned, leaving only their edges visible in today's maps. The process is not mysterious. Sea level acts like a tide on a planetary scale. When water is stored in ice, the sea retreats, exposing shelves. When ice melts, the sea rises and the shelves sink beneath waves.
What complicates this rhythm is that not all shelves are shaped the same. Some are broad and flat, stretching hundreds of kilometers. Others are narrow, dropping steeply into the deep. Each has its own story of exposure and flooding, written in sediments and slopes. Here we must pause and admit what we do not know. Much of the evidence is buried under water and mud. Excavating or mapping shelves requires complex tools, sonar, drilling, remote sampling. Even then, interpretation is cautious. We find river channels etched across the seabed, but we cannot always say which valley they belonged to. We discover sand ridges, but we do not always know whether they were dunes on dry land or bars formed by tides. The absence of clear answers does not erase their past. It only shows us the quiet limits of our vision. Still, the shelves speak in indirect ways. Fossil reefs tell us where the shoreline lingered for thousands of years. Cores of seabed sediment reveal transitions from soils to marine mud, from pollen-rich layers to shell-bearing clays. Submerged river valleys, traced by sonar, show pathways once carved in air. Even stone tools, sometimes dredged from fishing nets, hint that humans walked where fish now swim. These are fragments, but together they sketch outlines of landscapes long gone. Now let us imagine, slowly, how it might have felt. Step 1. Picture a broad plain where today the sea lies, stretching outward from the familiar coast. Rivers cross it, animals graze, and perhaps groups of people move across its valleys. Step 2. Over centuries, the sea creeps inward. Marshes form, salt touches soil, rivers widen into estuaries. Step 3. The plain is fully drowned, and only the higher ridges remain as islands above the new water. From a human view, each step might seem gradual, manageable. From the view of the earth, it is simply one more breath in the cycle of land and sea. Before we move on, let us note a subtle truth. These shelves are not empty even now. They remain places of life, nurseries for fish, grounds for corals, holders of ancient sediments. They are not dead lands, but transformed ones. Their past as plains and forests does not vanish. It becomes part of the layered identity of the seabed. The careful conclusion we can draw is that continental shelves are neither wholly land nor wholly sea. They are shifting frontiers, sometimes one, sometimes the other, always preserving traces.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. In their gentle slopes, we can still see the memory of vanished coastlines, the breathing edge of continents that has changed countless times before and will change again. If we let this thought settle, it brings not alarm, but perspective, the recognition that the map of the world has always been wider, and the seas have always visitors as well as residents. What if the land that once connected Britain to mainland Europe had never been swallowed by the sea, and the island we now know had remained part of a wider plain? This place, which researchers call Doggerland, lay across what is now the North Sea. For thousands of years, it stretched as a bridge of lowlands, full of rivers, lakes, and marshes. People lived there, animals roamed, plants spread across wide meadows. It was not an empty space,
but a living landscape, gradually reshaped as ice melted and seas rose. To imagine its scale, we can think of an area larger than many modern countries, yet now hidden entirely beneath waves. The process that drowned Doggerland was not sudden. As the last ice age ended, waters slowly crept over its plains. At first, marshes expanded, then rivers widened, and shallow lakes grew saltier. Over centuries, more land sank until the sea claimed nearly all of it. By the time of recorded history, Doggerland was already gone, its memory erased from maps but preserved in the seabed. We should pause here, because the details are uncertain. We cannot reconstruct every hill or path. What we know comes from fragments. Fishing trawlers sometimes bring up bones of mammoth or deer, or tools shaped by human hands, drawn from the seabed like messages from another time. Sediment cores reveal pollen and seeds that speak of forests and meadows. Sonar scans trace the outlines of ancient rivers that once meandered across the plain. Yet these glimpses are partial. The ocean has shifted and buried much. Absence of full evidence does not mean the absence of life, only that much remains beyond reach. Now let us linger on the language of these traces. The bones tell us which animals lived there: reindeer, aurochs, wild horses. The pollen shows us that birch and pine once grew, later joined by oak as the climate warmed. Tools and hearth remains remind us that humans adapted, hunting, gathering, perhaps settling for seasons at a time. Each signal is faint, but together they weave a picture of a world both familiar and strange. Let us try a gentle thought experiment. Step 1. Imagine standing on Doggerland 10,000 years ago. To the west, we might see hills where Britain now lies. To the east, the flat lowlands of Europe. Rivers run between them, and herds of animals graze. Step 2. Centuries pass. The rivers deepen into estuaries, marshes expand, and salty lagoons form. People notice that places once dry now flood more often. Step 3. The sea covers nearly everything. What were once paths are now channels. What were once meadows are now sandbanks under shifting tides. The land disappears, but its memory lingers in the scattered fragments beneath. Before moving further, let us note that the story of Doggerland is not unique. Other shelves and plains also drowned. Yet this one captures attention because of its position, connecting lands we now consider separate. Its absence shaped history, making Britain an island, influencing movement, trade, and culture. If it had remained dry, perhaps human paths would have unfolded differently. But speculation must remain gentle. We know enough to glimpse possibilities, not to draw firm alternatives. The careful conclusion is that Doggerland is both a vanished land and a reminder of how fluid maps truly are. Beneath the calm waters of the North Sea lies a hidden archive, holding bones, seeds, and tools that speak softly of lives lived on ground now unseen. By attending to these traces, we sense the rhythm of time, the way landscapes shift, and the way seas right over plains without haste, leaving only whispers for us to find much later.
What if the Black Sea, calm and closed as we see it today, was once a very different body of water? A wide freshwater lake surrounded by fertile plains. Some researchers suggest that thousands of years ago, its shores stretched far beyond the present boundary, its surface lower, its water sweeter, fed by rivers rather than tides. Then, as ice melted and seas rose, the barrier at the Bosporus may have given way, allowing the Mediterranean to pour in. In the scale of human lives, this would have been sudden, though in the measure of geology, it was only a moment. The quiet lake became a salt sea, and the old coast slipped beneath waves. To picture this, we can imagine a reservoir filling. At first, the lake sits in balance, isolated, its level steady. But once a channel opens, water rushes in, equalizing heights. For the Black Sea, this may have meant a rise of many tens of meters, flooding valleys and plains in a short span of time. Villages or camps along the shore would have seen their land swallowed, forests replaced by bays, rivers redirected. Yet we must pause and acknowledge uncertainty. Not all scholars agree on the scale or speed of this flooding. Some argue for a gradual transition, with water seeping slowly rather than rushing. Others see evidence of a more abrupt event, dramatic on a human scale. The sediments hold clues, but not complete certainty. Layers of shells, changes in salinity recorded by microfossils, shifts in isotopes of oxygen, all suggest a transformation, but the details remain open to interpretation. Absence of clear proof does not cancel the story. It only reminds us to be gentle with conclusions. Now let us linger on the traces left behind. In cores taken from the seabed, we find sudden switches from freshwater species to marine ones. Tiny plankton that tell us what kind of water they lived in. We find old river channels now drowned, their mouths shifted far inland. We find shorelines cut into rock, now deep below the surface. These indirect signals weave together into a quiet narrative of change, one that shaped not only the land, but perhaps the memory of the people who lived there. For it is in this story that some researchers see echoes of ancient myths. Tales of great floods appear in many traditions, from Mesopotamia to the Mediterranean. While we cannot equate myth directly with geology, we can note that people often preserved memories of natural events in stories. A sudden rise of the Black Sea might have lived on in oral tradition, reshaped across generations into warnings, into parables, into the language of legend. We will return to this idea of memory later, but for now, we simply note the possibility. Let us try a small thought experiment. Step 1. We stand on the shore of the ancient lake, with reeds at the edge and villages nearby. Step 2. The water begins to rise, at first slowly, then faster, day by day, taking more ground. Step 3. The lake is no longer the same. Its taste is salt, its level higher, its coastlines redrawn. What was once farmland is gone. What was once a home becomes seabed. From our point of view, the change is profound, but in the long measure of the earth, it is only one more reshaping of land and sea. Before we move further, let us remember that the Black Sea is not unique. Other basins have shifted from lake to sea, from freshwater to salt, from one identity to another. But here, the traces are close to us, well studied, layered in mud and shells that we can still retrieve. Each layer is a quiet page of history, showing us that the map of water is never still. The cautious conclusion is that the Black Sea story, whether sudden or gradual, is a reminder of transition. It shows us how coasts are drawn and redrawn, how human memory may hold shadows of these changes, and how science approaches them with care, never rushing to certainty. The surface we see today is only the latest version of a landscape that has worn many faces, each one written softly in sediments and carried forward in time.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. What if many of the islands we see today were once connected by land, parts of a larger whole rather than separate fragments scattered across the sea? During colder ages, when water was bound in ice and the oceans lay lower, vast stretches of ground linked what are now isolated coasts. In Southeast Asia, for example, large islands such as Borneo, Sumatra, and Java were joined together with the mainland in a single landmass called Sundaland. Wide plains stretched between them, crossed by rivers, forests, and wetlands. This was not a chain of islands, but a broad, continuous region. Only when the seas rose did the ridges of this land remain above water, turning into islands while the valleys drowned. To understand this, we may think of a mountain range. When the sea is low, the valleys are dry, the slopes are wide, the peaks seem less lonely. As the sea rises, the valleys fill with water, and the high points stand apart, now seen as islands. It is the same land, only seen differently, shaped by the level of the ocean. The mechanism behind this transformation is the same we have seen before. As glaciers melted, water returned to the seas, lifting them higher. The low areas between ridges drowned first, cutting the bridges that once connected regions. Gradually, what was once a plain became a strait. What was once a forest became a bay. People and animals who had moved freely now faced water as a barrier. This reshaping unfolded over centuries, but its effects were lasting. We should pause here to acknowledge what we do not know. The exact outlines of Sundaland or of other drowned land bridges are still reconstructed only in part. Maps are drawn from sonar scans, sediment cores, and scattered finds of ancient shorelines. Yet details blur. Some coastlines are uncertain. Some valleys have shifted. We cannot claim precise borders. What we can say is that the general picture is clear. Where there is deep water today, there was once land connecting the islands. Now let us linger for a moment on the traces left behind. Beneath the shallow seas of the region, researchers find drowned river channels etched into the seabed like hidden maps. Pollen grains in sediment layers reveal tropical forests once growing where the ocean now lies. Even animal remains tell part of the story, showing migration routes that made sense only when the land was connected. These indirect markers allow us to piece together a vision of landscapes now unseen. Let us try a gentle thought experiment. Step 1. Imagine walking across a wide plain, stretching from the mainland toward what we now call Borneo. Forests surround us, rivers cut their paths, and animals move freely. Step 2. Centuries pass, and the sea creeps inward. Low valleys flood first,
cutting rivers into estuaries. What was once a straight path now bends around growing bays. Step 3. The water deepens. Plains are gone. Forests shrink to ridges, and the highlands remain as islands scattered in the sea. The land we knew still exists, but it is hidden below, waiting quietly under the waves. Before moving further, let us note that such drowned connections are not unique to Asia. Similar land bridges once linked Australia to New Guinea and Tasmania, and even the British Isles to Europe. Each case shows us how seas shape the flow of life, deciding whether movement is free or restricted. The rising waters turned continuous lands into scattered islands, altering paths of migration, trade, and settlement. The cautious conclusion is that islands are not always as isolated as they appear. They are often the peaks of larger lands, fragments of broader regions reshaped by the breathing of sea levels. In their separation, we see not beginnings but continuations of a longer rhythm, where land and water exchange places with quiet persistence. If we let this thought rest, it becomes clear that the seas have always been map makers, cutting and joining, dividing and reconnecting, leaving traces in sediments, in valleys now drowned, and in the patterns of life that still carry echoes of those ancient connections.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. What if the stories told around fires, whispered across generations, hold faint reflections of coastlines that no longer exist? Human memory is fragile, yet it sometimes preserves impressions of events far older than a lifetime. Myths of floods, tales of lands that sank beneath the sea, or stories of journeys across vanished bridges may be echoes of the slow rise of waters after the ice melted. We cannot say for certain which tale corresponds to which event, but the persistence of such themes suggests that people noticed and remembered change. To place this thought in context, we must imagine ourselves in communities that lived close to water. For them, the shore was both a boundary and a resource. When the sea crept inland, fields turned to marsh, and marshes to bays. The change may have felt gradual, but when told across generations, it could be remembered as a great transformation. A flood in memory need not be a single storm. It may be the distillation of centuries of rising tides. Oral tradition often compresses time, turning long rhythms into a single image. Now let us pause and admit the limits of what we know. Myths are layered. They change with each telling, shaped by culture and belief. We cannot use them as direct maps of the past. Absence of precise detail does not mean absence of connection, but it does mean we move carefully. We can suggest parallels, not proofs. Still, we find patterns that are hard to ignore. Tales of drowned lands appear in many regions. The lost land of Lyonesse near Cornwall, the city of Atlantis described by Plato, the flood myths of Mesopotamia, or stories from indigenous peoples in Australia of coastlines that stretched farther out. While each is different, the recurring motif of land claimed by the sea suggests a shared human recognition of shifting shores.
The language of these stories becomes another kind of archive, softer than stone, but enduring in its own way. Now let us linger on the indirect markers such stories leave. Linguists note place names that reference shallows or fishing grounds far offshore, perhaps pointing to older geographies. Folklore scholars trace similarities between distant traditions, suggesting common experiences of rising water. When matched with geological records, sediments, drowned forests, ancient river channels, the resonance deepens. The alignment is not perfect, but it is suggestive, like two melodies playing in harmony without being identical. Let us try a gentle thought experiment. Step 1. Imagine living on a coast where the sea rises slowly, a few centimeters each year. Each generation notices small changes but adapts, moving dwellings, shifting fields. Step 2. After centuries, the shoreline has moved far inland. The memory of the old coast survives only in stories told to children. Step 3. After many generations more, the land is fully drowned, but the story remains, describing a flood or a sinking land, shaped into myth. In this way, human memory stretches farther than we might think, though always blurred by time. Before we move on, we may note that not all myths have geological roots. Some may have arisen independently, shaped by imagination, symbolism, or ritual needs. We must hold both possibilities. The absence of direct correlation does not diminish their value. Instead, it reminds us to approach them as one strand of evidence among many, part of a wider fabric. The careful conclusion we can draw is that myths and stories may carry faint reflections of real landscapes now hidden beneath the sea. They are not maps, but memories transformed, poetic records of change. When read alongside sediments and stone, they enrich our understanding, showing that people have long observed the shifting boundary of land and water. If we let this thought settle, it becomes a reminder that human culture is also an archive, one that whispers of drowned coastlines in its own quiet, enduring language.
What if the ice itself could be read, peaceful, quiet, and relaxing? It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. What if the ice itself could be read as a book, holding in its frozen layers the memory of seas long past and climates that shaped coastlines? Glaciers and ice sheets are more than frozen landscapes. They are archives, preserving fragments of air, dust, and water chemistry from the time they formed. When snow falls, it traps tiny bubbles of atmosphere between its crystals. Over centuries, as more snow presses down, these layers compress into ice, sealing away the air of earlier worlds. By drilling deep into the ice, scientists retrieve cores that act like long scrolls of time. Each meter corresponds to centuries, sometimes millennia. In these fragile tubes of ice, we find a record of temperature, rainfall, volcanic eruptions, even hints of how much seawater was locked away at different times. To make this clearer, we can think of the ice as a layered cake. Each layer holds small ingredients, dust, salt, air, that reflect the environment of the year it was formed.
By studying these layers carefully, we learn when ice grew and when it melted, when seas retreated and when they rose. Now let us pause to acknowledge limits. Ice cores are not perfect. Layers can shift, melt, or deform under pressure. Some records are lost, blurred beyond recognition. Not every glacier has been sampled, and not every region preserves a continuous archive. The absence of data does not mean nothing happened, only that the evidence is incomplete. So we proceed with care, aware of uncertainty, careful not to force certainty onto silence. Still, the language of ice is rich. Isotopes of oxygen within the ice crystals tell us how warm or cold the air was when the snow fell. Higher ratios suggest warmer periods, lower ratios colder ones. The amount of trapped greenhouse gases, carbon dioxide, methane, shows us how the atmosphere changed in tandem with temperature. Even tiny particles of sea salt or volcanic ash drifted into the ice, settling in layers we can still measure. These signals are indirect, but together they allow us to reconstruct the rhythms of ice growth and melt, and thus the ebb and flow of shorelines. Now let us imagine a gentle thought experiment. Step 1. Picture a glacier at the height of an ice age. Snow falls, locking water away from the ocean, and the sea level drops. Coastlines stretch outward, exposing shelves and valleys. Step 2. Centuries pass, the air warms, and the glacier begins to retreat. Meltwater flows back to the sea, filling its basins. The ice core records this in changes of isotopes and trapped gases. Step 3. Long after the glacier has melted, we drill into the remaining ice and read those signals, learning that the rise of the sea was written in frozen bubbles and crystals. In this way, the ice becomes not only a participant in the story, but also a witness. Before moving further, we should note that these ice records do not speak of specific coastlines. They do not tell us of one drowned valley or one vanished plain. They give us instead the broader rhythm: how much ice existed, how fast it melted, how much water returned to the oceans. From this rhythm, we infer the rest, combining the ice with sediments, corals, and drowned landscapes. The careful conclusion is that glaciers hold one of the most delicate yet powerful memories of our planet's changing seas. Their frozen archives allow us to glimpse the scale of past shifts, even if we cannot map every detail. When we read their signals, we are reminded that the coastlines we know today rest upon the patient balance of ice and water. And if we let the thought settle, it becomes clear that ice, though silent, is one of the most eloquent storytellers of all, speaking softly in bubbles, layers, and crystals about the ancient horizons where land met sea. What if reefs, those delicate structures built by countless tiny creatures, are not only homes for life, but also quiet rulers of time, keeping record of the sea's slow movements? Corals grow upward toward the light, needing shallow water to survive. When seas rise, they grow higher.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. When seas fall, they are left stranded above the waves, their growth frozen in place. In this way, coral reefs become natural markers of sea level, staircases of stone and skeleton that trace the rhythm of oceans through ages. To understand this, let us imagine how a reef forms. Small coral polyps, animals no larger than a grain of rice, build limestone skeletons around themselves. Over centuries, their colonies grow into vast walls and ridges. These structures are fragile in life, yet enduring in death, preserved as fossil reefs long after the living corals have passed. Each layer of growth reflects the conditions of the sea at that time, its depth, its temperature, its chemistry. By drilling cores through ancient reefs, scientists read these layers like rings in a tree. They find patterns of rise and pause, times when seas advanced quickly, and times when they lingered. Yet here we must pause, for reefs do not tell us everything with clarity. Growth can be interrupted by storms, disease, or shifts in water quality. Some reefs collapse, others erode. What is missing in one record may be preserved in another. We must assemble the fragments carefully, always aware that absence of growth does not always mean absence of change. Still, the language of reefs is rich. Their calcium carbonate skeletons preserve isotopes of oxygen that reveal past water temperatures. The depth at which fossil reefs are found tells us where the sea once stood. In the Pacific, fossil terraces step upward along coasts, each one marking an old shoreline where reefs once grew. In the Caribbean, cores from submerged reefs reveal periods when sea level rose at different speeds, sometimes slowly, sometimes in pulses. These traces do not give us exact dates for every moment, but they sketch a rhythm, soft yet consistent. Now let us try a small thought experiment. Step 1. Imagine a coral reef in a shallow bay. The water is calm, light reaches the bottom, and the corals grow steadily upward. Step 2. Over centuries, the sea begins to rise. The corals follow, building higher, always close to the surface. Fish and other creatures move with them, the reef becoming both home and archive. Step 3. Long after, the reef is drowned too deeply to grow further. The corals die, but their limestone remains, a monument to a sea level that once paused there. Later still, scientists study it, learning from its height how far the sea had climbed. This gentle cycle shows how reefs are not only living systems, but also geological records. Now, before moving further, we should note that reefs respond differently in different places. In some regions, growth keeps up with rising seas. In others, reefs cannot match the pace and are drowned. The variety reminds us not to seek a single story, but many overlapping ones. Each reef is a local witness, telling of its own stretch of water, its own balance of growth and submergence. The careful conclusion we can draw is that coral reefs are both fragile and enduring. Fragile in life, dependent on light and clear water, yet enduring as stone, preserving traces of sea levels across ages. By listening to their layered skeletons, we sense the rise and fall of oceans, not in dramatic leaps, but in steady climbs, in pauses, in subtle steps written in limestone. If we let this thought settle,
reefs become more than habitats. They are calendars of the sea, marking its quiet changes with patience, reminding us that the boundary between land and water is always in motion, always recorded in living stone. What if shorelines are not fixed lines at all, but breathing boundaries, shifting with the slow rhythm of the earth? When we look at a map, it may appear permanent, as though coasts have always been drawn the same. Yet in the scale of thousands of years, the sea advances and retreats, reshaping edges of continents with patience. To see this rhythm, we must step back, leaving behind the timescales of days or centuries, and move into the language of ice ages and interglacial warmth. In colder ages, water is locked in vast ice sheets, and seas retreat.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. Uncovering wide plains. In warmer ages, ice melts and seas return, covering what was once land. The process is not dramatic in a single year, but across millennia it is profound. The rhythm is not simple either. It is not a straight line of rise or fall, but a pattern of cycles. The Earth tilts, its orbit shifts. The amount of sunlight varies slightly. These slow astronomical rhythms, known as Milankovitch cycles, guide the growth and retreat of ice. Over tens of thousands of years, they repeat, like the ticking of a quiet clock. Ice responds by advancing or shrinking, and the seas follow in their own time. Now let us pause to admit the limits of our knowledge. We can trace these cycles through data, through ice cores, through coral terraces, through sediment layers. But we cannot predict every detail. Local conditions vary. Some coasts rose even as others sank, pressed by the weight of ice or lifted when that weight was gone. Absence of a terrace in one place does not mean the sea stood still. It may simply mean the land moved differently. We hold these uncertainties gently, listening for patterns rather than final answers. Still, the language of the earth is clear enough. We find reefs stranded high above present seas, proof of higher waters in the past. We find drowned valleys stretching far under water, proof of lower seas when ice was greater. We find alternating bands of sand and mud, each marking shifts between land and water. These indirect signals together compose a story of breathing shorelines, of edges that are always temporary. Let us imagine, step by step, what this means. Step 1. A cold age arrives. Glaciers spread, water is locked away, seas fall, and new land emerges. Rivers carve deep valleys across the exposed shelves. Step 2. The air warms. Ice melts, seas rise, and those valleys are drowned, becoming estuaries, then seabeds. Step 3. The cycle continues, slowly, with another cooling, another retreat, another return. Each step takes thousands of years, but together they form a rhythm that has repeated many times. Before we move further, let us note that humans have lived through only part of this rhythm. Our earliest ancestors saw seas lower than today. Our more recent ancestors saw them rise.
The coastlines we know are only a snapshot in a much longer cycle. This perspective reminds us that permanence is an illusion. The shore is always in transition. The careful conclusion is that shorelines are living boundaries, moving with the pulse of climate and ice. They are not lines carved once, but lines redrawn again and again, slowly, softly, with time. By listening to the archives, ice, corals, sediments, we sense this rhythm, even if we cannot chart every moment. If we let this thought rest, it brings a kind of calm, the recognition that change is not an interruption, but the natural breathing of the earth, a reminder that what we see as fixed is always part of a greater flow.
Archaeology is slow. Divers and machines map the seabed, scanning for shapes that stand out from natural formations. Sonar reveals channels of ancient rivers. Cores of sediment bring up grains of pollen or charcoal from long-vanished forests and fires. These are indirect markers, but together they suggest where people might once have lived. Tools made of flint or bone show us human hands. Charcoal fragments hint at controlled fire. Shell heaps, preserved under mud, speak of meals eaten at the edge of ancient shores. Now let us pause to acknowledge limits. Much is lost to currents, to salt, to time. Wood decays, fabrics vanish, even stone can be shifted. We cannot hope for complete villages or full records. The absence of finds does not prove absence of life. It may only mean that preservation failed. This is why interpretations remain cautious, built from fragments rather than firm maps. Yet the language of traces still speaks. In Europe's North Sea, tools and bones from Doggerland appear in trawl nets. In Australia, submerged sites along the shelf preserve hearthstones and stone artifacts. In the Mediterranean, drowned caves show charcoal layers left by fires. Each example is incomplete, yet each adds to a growing archive that whispers of human presence where the sea now lies. Let us try a gentle thought experiment. Step 1. Imagine a small group of people camped beside a river on a wide plain. They hunt, they gather plants, they light fires. Step 2. Centuries pass, and the sea creeps inland. The river mouth grows brackish. The camp is moved further up the valley. Step 3. The plain is drowned. The fire pits and tools are covered by silt, sealed away beneath waves. Thousands of years later, a diver or a sonar scan reveals faint signs. What was daily life has become an archaeological layer. Now, before we move further, let us note that this archaeology underwater is not only about people. It also records their environment. Pollen tells of forests, bones of animals, shells of shifting coasts. These indirect signals give us a broader picture, showing not just presence but context. Through them, we learn how people adapted to change, moving with the sea, always adjusting, never fixed. The careful conclusion is that the drowned coasts hold human stories, though only in fragments. We may never reconstruct them fully,
But even partial traces are enough to remind us that the ocean floor was once a lived-in landscape. If we let this thought rest, it becomes clear that archaeology here is less about discovery than about listening. Listening to sediments, to stone, to quiet remains. It is a reminder that our own place on the shore is temporary, part of the same long rhythm of land and sea, written not in words, but in the faint marks left behind. What if the artifacts we find on the seafloor are not random fragments, but quiet signals, reminding us that people once lived where water now moves? The ocean, though vast, does not erase everything. Sometimes it hides, sometimes it preserves. In mud, sand, and silt, traces of tools, pottery, or hearthstones remain, waiting to be noticed. These objects do not tell full stories, but they hint at habits, at presence, at everyday lives along vanished coasts. To understand this, let us place ourselves in the long time scale of human movement. People have always chosen to live near water. Rivers gave fresh supplies, coasts gave food, wetlands gave fertile soil. When sea levels were lower, vast areas of coastal plain stretched beyond today's shorelines. Families gathered there, built shelters, shaped tools. Later, as the sea advanced, their landscapes were drowned. What they left behind was covered by layers of sediment, sealed in quiet darkness. Now we may linger on how these traces come back to us. Fishermen dragging nets sometimes bring up flint blades, smoothed by thousands of years under the sea. Divers exploring shallow shelves have found wooden stakes or fragments of pottery. In rare places, whole structures are preserved, such as stone walls or patterns of post holes, telling of...
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. Settlements once standing on dry land. Each find is fragile. Salt and water corrode, currents scatter. Much is lost. Yet even a single fragment is enough to remind us that these spaces were once alive. Now let us pause to acknowledge limits. An artifact out of place does not always reveal its full meaning. A stone flake may be natural rather than shaped. A wooden beam may have drifted rather than stood in a dwelling. Absence of artifacts does not mean people were not there. The sea is selective in what it keeps. We read cautiously, always aware of what might be missing. Still, the language of artifacts speaks in subtle ways. Patterns of flint tools tell us of hunting and gathering. Pottery shards suggest cooking, storage, shared meals. Charcoal traces point to controlled fire, perhaps warmth or ritual. Bones of animals found in clusters hint at feasting places. These are not loud voices, but whispers, each adding to the wider fabric of memory. Now let us try a thought experiment. Step 1. Imagine a small community living on a broad plain, building fires near a river mouth. Their tools lie scattered where they worked. Step 2. Centuries pass. The sea advances. Tides cover the plain, and the tools sink into mud. Step 3. Long after, we recover a flint blade from the seafloor. Alone it is silent, but placed alongside others,
Alongside pollen, shells, and sediments, it becomes part of a story. The daily life of people, the slow rhythm of rising seas, the transformation of coasts, all are folded into that single object. Before moving further, let us note something important. These finds, though fragmentary, connect us to the rhythm of adaptation. People did not vanish when the sea came. They moved inland, they adjusted, they carried traditions with them. What was left behind is only a shadow, but it tells us of resilience, of continuity. The careful conclusion is that underwater artifacts are not simply relics, but markers of human presence, preserved where we least expect them. They do not offer certainty, but suggestion, not complete maps, but outlines. If we listen gently, they remind us that the seafloor was once landscape, that beneath the waves lie traces of homes and lives waiting in silence. And if we let this thought settle, it brings a sense of continuity, that even in change, human presence leaves quiet marks, carried forward by the patience of water and time. What if the ocean itself were a vast archive, holding within its waters the faint signatures of past climates and drowned coastlines? Unlike stone or ice, this archive is not solid but fluid, and yet it preserves traces that can be measured with care. Seawater carries within it tiny variations called isotopes, which record the balance between ice and liquid, between cold and warmth. These signals are delicate, invisible to the eye, but they tell us of the shifting edge between land and sea. To place this thought in context, we must consider time on the scale of tens of thousands of years. When ice sheets grow, they lock away lighter forms of oxygen, and the ocean becomes slightly heavier in its isotopic balance. When ice melts, the lighter isotopes return, and the sea shifts back. By studying the shells of tiny marine organisms that built their skeletons from seawater, we can read these changes layer by layer. It is as though each shell is a diary entry, written in chemistry, about the state of the Earth when it lived. Now we should pause to admit the limits of this method. Isotopic signals can be blurred by currents, by local conditions, by processes we do not fully understand. One record may suggest a rise or fall in sea level, while another shows something different. The absence of clarity does not erase the history. It only reminds us that the ocean's language is complex, not easily translated. Still, by combining many records from many places, a pattern emerges, one that tells of great ice ages, of warming phases, of seas advancing over plains. The language of isotopes is not the only way the ocean speaks. Layers of sediment at the bottom of seas hold clues in their grain size.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. Their color in the presence of pollen or volcanic ash. Each thin sheet of mud or sand is a quiet entry in a long archive, showing how rivers carried soil, how winds blew dust, how ecosystems shifted. Taken together, these marine archives give us a layered story, incomplete yet steady in its outlines. Now let us try a gentle thought experiment. Step 1. Imagine a warm age. Seas are high, and corals grow near the surface. Shells formed in this water carry isotopic signatures of warmth and abundance.
Step 2. Centuries later, the world cools, glaciers grow, and seas fall. The organisms that live then carry a different signal, reflecting colder water, heavier isotopes. Step 3. Long after, scientists retrieve cores of sediment from the seabed. Within them, they find shells from both times, layered above one another, silent but eloquent. From these layers, they reconstruct the rhythm of the seas, the hidden coastlines that came and went. Before we move further, let us linger on the patience required. These records are not dramatic, not full of detail. They do not tell us the name of a drowned river or the exact outline of a lost plain. They tell us instead the broad sweep, the rise and fall, the gentle breathing of the ocean over millennia. And in their quiet way, they remind us that the seas we know today are only one chapter in a long series of changes. The careful conclusion is that the ocean itself is both a force and a witness. Its waters reshape the coasts, and its chemistry preserves traces of those very changes. Though the signals are subtle, though our interpretations remain cautious, the message is steady. Coastlines are never fixed, only borrowed, always moving with the larger balance of ice, water, and time. If we let this thought rest, it brings us to a calm recognition that the ocean is not only present, but also memory, a flowing archive that carries within it the long story of vanished lands. What if the story of drowned coastlines is not told by land alone, but also by the lives of animals that moved across them? For creatures both great and small, the shifting of the seas redrew paths, reshaped habitats, and altered migrations. When we listen to these patterns in bones, in fossils, and in the distribution of species, we hear another quiet voice of the vanished shores. The scale of this record stretches across tens of thousands of years, into times when herds of mammoths walked across plains that are now seabeds, and when shallow channels were not barriers, but corridors. To place this in context, we must remember that animals, like people, sought fresh water, grazing lands, and safe ground. When ice bound the seas and waters lay lower, vast plains appeared, rich with grass and rivers. Herds crossed these expanses, predators followed, and people moved with them. Later, as seas rose, the corridors closed. What had been a broad steppe became scattered islands. The rhythms of animals changed, and their remains were left behind in places we now dredge or dive. Now let us pause on the limits of our certainty. Fossil bones recovered from the seabed may tell us of presence, but not always of abundance. A tusk caught in a trawler net might have drifted before burial. A skeleton eroded from sediments may have moved from its original place. The absence of clear patterns does not mean the past was empty. It only reminds us that time and tides scatter as much as they preserve. Still, there is a language here, written in indirect signs. In the North Sea, bones of mammoth, woolly rhinoceros, and reindeer appear, carried up from the drowned plain once called Doggerland. In Southeast Asia, remains of large mammals show that Sundaland was once a continuous habitat. Even along Australia's drowned shelves, traces of megafauna hint at grazing lands now hidden. These fragments, though scattered, speak of ecosystems as alive and complex as any modern savanna. Now we may try a gentle thought experiment. Step 1. Picture a plain, wide and open, where mammoth herds graze and rivers thread across the land.
Centuries pass and the sea begins to rise. Marshes spread, herds are forced inland, corridors narrow. Step 3. The plain is gone. Herds retreat to higher ground, and the bones of those that remained sink into mud, sealed beneath the waves. Thousands of years later, we recover fragments, enough to remind us of that vanished step. Before we move further, let us note that these changes were not only about loss. New coasts formed, new estuaries opened, new habitats appeared. Fish and marine mammals expanded into spaces that were once land. Birds adapted, nesting on cliffs that became islands. The shift was not only an ending, but a transition, one system giving way to another. The careful conclusion is that drowned coastlines are also remembered through the lives of animals. Their bones, their paths, and their absences tell us of the shifting balance between sea and land. We cannot reconstruct every detail, but we can sense the broad pattern. Corridors turn to channels, plains turn to seabeds, migrations altered by the slow breath of the oceans. If we let this thought settle, it brings perspective, reminding us that we share these rhythms with the rest of life, and that the traces of drowned worlds remain not only in stone and sediment, but also in the quiet testimony of animals that once walked where waves now move. What if the layers of sand and mud that rest quietly on the seabed are not just deposits of nature, but long archives, recording each shift of shoreline and climate? Sediments, though soft and unassuming, hold within them the memory of floods, of forests, of seas. Each thin layer tells of a time when grains were carried by wind or water, settled and sealed away. Over centuries, these layers stack, forming a slow, silent record that can be read by those who know how to look. To place this in context, we must imagine scales of thousands, even millions of years. Sediments fall grain by grain, but over deep time they build into sequences many meters thick. Within them lie fossils of plants and animals, chemical signals of water's salinity, even tiny fragments of volcanic ash carried across continents. When we drill cores through these sediments, we bring up a column of time, each layer a page written by the earth itself. The mechanism is simple, though patient. Rivers carry soil into seas. Winds sweep dust across oceans. Floods wash organic matter into bays. Once settled, these particles become trapped, compressed under later layers. Just as dust on a shelf can show us how long it has been since it was last cleaned, so too do sediments show us how long it has been since a shoreline stood in one place. Yet we must pause and admit what we do not know. Sediments can be disturbed by currents, by burrowing animals, by storms. Some layers erode before they can be preserved. Others are compacted until their signals blur. The absence of a layer does not mean an event never happened. It may simply mean the archive was interrupted. We approach these records with caution, piecing together fragments, aware of their silences as much as their words.
Still, sediments speak in their own quiet language. Grains of pollen reveal forests that grew on coasts now drowned. Shifts in isotopes of carbon show changes in vegetation and climate. Layers rich in shells tell of marine transgressions, times when seas advanced. Layers of peat or soil hint at regressions, times when land stretched outward. Even the color of mud, dark with organic matter or pale with sand, signals the conditions under which it formed. Now let us try a gentle thought experiment. Step 1. Picture a river delta during a time of low seas. The river spreads wide, depositing sands and silts on plains. Plants grow, and their pollen drifts into the layers. Step 2. The sea rises. Estuaries form, salt water advances, and new sediments bury the old. Marine shells settle on top of plant-rich mud. Step 3. Long after, a core is drilled through the seabed. The sequence of layers tells the whole story. Plains, marshes, estuaries, seas.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. In sediments, each preserved with quiet patience. Before we move further, let us note the reach of this method. Sediments do not only tell of coastlines, they tell of climates, of storms, of volcanic events. A layer of ash may mark a distant eruption. A spike in certain isotopes may reflect a sudden warming. By reading sediments, we glimpse not only the places where coasts once stood, but also the wider stage on which those coasts were shaped. The careful conclusion is that sediments are humble yet powerful witnesses. They do not give us vivid images or clear maps, but they offer continuity, an unbroken chain of small signals that, when read together, reveal the rhythm of land and sea. If we let this thought rest, it brings perspective. That the soft mud beneath the ocean is not just the floor of today's seas, but a library of time, holding within it the memory of drowned coastlines, written slowly, layer upon layer, by the quiet hand of the earth. What if the drowned coastlines could be traced not only through stone and mud, but through the shells of living creatures that once thrived along them? Mollusks, corals, and small plankton build their shells and skeletons from seawater, locking into their structure tiny signals of temperature, salinity, and chemistry. When they die, their remains settle into sediments, preserved as quiet records of the water in which they lived. By studying these micro-archives, we begin to sense the shifting boundary between land and sea, not through direct maps, but through the language of biology. To place this in context, we must imagine the scale of time measured not in centuries, but in layers of shell beds stretching across thousands of years. In some drowned valleys, we find thick deposits of oyster shells, once part of shallow estuaries. In deeper basins, layers of microscopic plankton accumulate, each species responding to temperature and nutrient changes. Together, these remains give us subtle but enduring markers of where shorelines once lay and how they moved as seas rose. The process works in a simple way.
A shell grows by adding material day by day, like the rings of a tree. Its chemistry reflects the water at the time of growth. When the shell is preserved in sediment, those signals remain. By analyzing oxygen isotopes, we can estimate the temperature of the seawater. By studying the species present, we can infer whether the environment was coastal, estuary, or open sea. In this way, the shells become storytellers, whispering of vanished bays and drowned plains. Yet here we must pause, for interpretation is not without limits. Shells can be transported by currents, mixed into layers that are younger or older than their original context. Some dissolve, leaving gaps in the archive. Others are overgrown or altered, their signals blurred. The absence of a species does not prove absence of its habitat. It may only mean the conditions of preservation were unkind. We approach these records carefully, piecing together multiple lines of evidence before drawing conclusions. Still, the language of shells is rich. Fossil oyster beds found beneath the modern seabed tell us where estuaries once spread. Microfossils of foraminifera, tiny shelled plankton, reveal past sea levels and water temperatures. Shifts in species over time mark the transitions from freshwater to brackish to marine conditions as seas advanced inland. Even growth lines within a single shell can reveal short-term events, storms, droughts, or sudden influxes of fresh water. Now let us try a gentle thought experiment. Step 1. Picture a wide coastal plain with shallow lagoons. Oysters and clams thrive, their shells piling up in natural beds. Step 2. Centuries pass, the sea rises, and the lagoons become deeper bays. New species replace the old, while the earlier shells are buried beneath silt. Step 3. Long after, we drill into the seabed and find those shells layered together. By analyzing them, we reconstruct the quiet story of a shoreline moving steadily inland, its memory held not in maps, but in calcium and isotopes. It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. Before we move further, we should note that these biological archives do more than record sea levels. They also reveal climate rhythms. Warmer seas encourage certain species, cooler seas others. By comparing shell records from distant coasts, we begin to see global patterns. Moments when seas everywhere were warmer, or times when ice held the oceans back. In this way, shells connect the local story of a single drowned bay to the broader pulse of the Earth's climate. The careful conclusion is that shells, humble and fragile, are among the most enduring witnesses of change. They outlast the creatures that built them, holding quiet memories of vanished coastlines in their structure. By listening to them through careful study, we gain glimpses of estuaries long gone, of seas advancing step by step, of climates shifting with time. If we let this thought rest, it reminds us that even the smallest forms of life contribute to the great archive of the earth, and that the edges of land and sea are written not only in stone, but also in the delicate skeletons of creatures that lived and died in those changing waters. What if the traces of drowned coastlines could be seen not only in sediments and fossils, but also in the very shape of the land beneath the waves? The seabed, though hidden from sight, still carries the outlines of valleys, rivers, and ridges that once lay above water. When we map these forms with sonar and satellites, we find patterns that resemble familiar landscapes. Meandering channels, delta plains, terraces cut by ancient shores. They are landscapes preserved in silence, waiting under layers of water. To understand this, let us imagine the sea as a thin veil. When it is lifted during low stands, land is revealed. Rivers carve, winds shape dunes. When the veil falls again, the sea covers these features, but does not erase them at once. They remain as ghostly imprints, sometimes buried in silt, sometimes clear and sharp, like footprints left in drying clay. By scanning the seabed with sound waves, researchers create images of these lost surfaces. The process is gentle yet powerful. Sound pulses travel downward, bounce off layers, and return, allowing us to build a picture of hidden valleys and slopes. These are not direct photographs, but echoes, interpreted with care, like shadows seen through fog. We must pause here and admit uncertainty. Some shapes on the seabed can be mistaken. What looks like a river channel may be a fault. What seems like a terrace may be an illusion of shadow. Absence of clarity in one region does not mean the land was never there. It may only mean the record is too deeply buried or too disturbed. Our reconstructions remain cautious, stitched together from many perspectives. Still, the language of the seabed is expressive. Submerged river valleys show us where fresh water once flowed. Ancient deltas spread outward, their channels frozen in place. Terraces mark former shorelines, like steps on a staircase, each one a pause in sea level before the water rose again. Sand dunes, now drowned, trace the paths of winds across dry plains. Together, these features form an atlas of coasts that no longer exist. Now let us try a thought experiment. Step 1. Imagine walking across a wide river plain, the channel winding slowly, depositing sand along its banks. Step 2. As centuries pass, the sea rises, covering the plain. The river mouth shifts inland, but the old channel remains carved into the land, now hidden beneath waves. Step 3. Much later, sonar scans reveal the meandering form, identical in shape to rivers we know today, only preserved in darkness. By following these patterns, we glimpse the drowned geography. Before we move further, let us pause on a subtle point. These landscapes, though hidden, influence the present sea. Submerged valleys guide currents, shape fisheries, and even affect where sediments settle. The past is not gone entirely. It still molds the present in quiet ways. Ancient ridges may become shoals. Ancient river mouths may guide estuaries. The memory of land lives on in the...
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. The behavior of water. The careful conclusion is that the shape of the seabed is itself an archive, one that complements ice,
sediments, and fossils. It does not tell us of people or animals directly, but it gives us the framework, the plains, the valleys, the shelves, on which those lives unfolded. If we let this thought settle, it reminds us that the earth does not forget easily. Even when drowned, the outlines of land remain etched in stone, waiting underwater, carrying the memory of coastlines that once breathed in the air and are now part of the quiet architecture of the sea. What if the memory of drowned coastlines is carried not only in the earth itself, but also in the language of the winds and currents that flow above them? The oceans are not still. They move slowly and steadily, guided by temperature, by salinity, by the shape of the basins beneath. These movements, currents, are like rivers within the sea, shifting warmth, carrying nutrients, and in their pathways we sometimes find hints of the lands that once stood in their way. To place this in context, let us recall that when sea levels were lower, the outlines of continents were broader. Currents flowed differently, diverted by plains that are now hidden. As the water rose, the geometry of the basins changed, and so too did the flow. What we observe today is only the latest arrangement of a system that has adjusted many times over long cycles. The mechanism behind this is simple, though vast. Warm water tends to move toward colder regions, while cold water sinks and slides back toward the equator. Saltier water sinks deeper than fresher water. Together, these factors create circulation patterns across the globe. When coastlines change, the pathways shift. A drowned ridge might become a channel guiding flow, while a submerged valley might funnel currents in new directions. We can still trace these effects, though cautiously, in the records left behind. Now we must pause to admit limits. We cannot reconstruct with certainty the exact patterns of ancient currents. The data are indirect. Sediment grains carried by flow, isotopes within microfossils showing temperature, chemical traces in deep-sea cores. These tell us of general conditions, not precise maps. The absence of direct evidence does not mean currents were absent. It only means the signals we hold are partial, blurred, incomplete. Still, the ocean leaves behind its quiet archives. In cores of sediment, we find layers of dust carried by winds and dropped far from land. Their presence tells us how air moved, and thus hints at the shape of continents that influenced those winds. In the shells of plankton, we read temperatures that reflect whether warm or cold currents passed above. Even in the distribution of nutrients recorded in the chemistry of sediments, we see the outlines of ancient flows. Together, these data allow us to sketch, though softly, how drowned coastlines reshaped the great circulations of the sea. Let us try a thought experiment. Step 1. Imagine a time when seas were lower and a broad plain stretched where now there is only water. Winds blow across it, shaping the climate on either side. Currents deflected along its edges. Step 2. The ice melts, the plain drowns, and suddenly currents find new paths, flowing where once there was land. Winds carry moisture differently. Rainfall shifts. Step 3. Long after, we study sediments, plankton shells, and isotopes, and we begin to see the faint signal of that transition, not as a vivid picture, but as a subtle rhythm in the data. Before we move further, we should note that these changes did not happen in isolation. The adjustment of currents influenced climate far inland, altering rainfall and vegetation. A drowned coastline was not only a local event, but part of a chain of consequences that spread widely. This reminds us that the land and the sea are never separate. They speak constantly through winds, through water, through temperature. The careful conclusion is that drowned coastlines can be traced not only by the landforms left.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. Beneath the sea, but also by the patterns of movement they once shaped in air and water. Though the evidence is indirect, though it requires patient reading, it reminds us of the deep interconnection between land, sea, and climate. If we let this thought rest, it brings a quiet awareness that the vanished shores continue to whisper, not only in stone and shell, but in the very rhythm of the oceans that flow across their memory. What if the memory of vanished coastlines is carried not only in stone, shell, or sediment, but also in the stories passed down through generations? Oral traditions, told around fires, sung in chants, whispered as myths, often preserve echoes of real landscapes now lost to the sea. Though wrapped in metaphor, these stories sometimes align with geological evidence, suggesting that memory itself can become a kind of archive, lasting long after the land it describes has gone. To set this in context, we must remember that people have lived beside coasts for tens of thousands of years. They watched the sea advance. They saw rivers change. They felt the loss of familiar ground. Without maps or written records, memory and story became the way to carry these events forward. Myths of floods, of drowned lands, of shifting shores are found across the world. They may not describe events with precision, but they reflect the lived experience of change. The mechanism of oral tradition is simple, though fragile. A story is told, learned, and told again. Each telling adjusts, but the core remains. Just as a pebble carried by a river is smoothed but not erased, so too are these narratives shaped by time, yet able to preserve an outline of truth. When researchers compare them to geological data, surprising connections appear. Yet we must pause here to acknowledge limits. Not every story refers to real events. Myths may arise for symbolic reasons, or as metaphors for human struggles. To assume that every tale of a flood is evidence of sea level rise would be careless. The absence of story does not mean absence of change. What survives is partial. What is forgotten may have been equally real. Still, the language of tradition offers clues. In Australia, Aboriginal stories speak of coastlines that are now far offshore, and their details align with geological reconstructions from thousands of years ago. In the Pacific, chants describe islands sinking, sometimes matching the timing of known sea level shifts. In Northern Europe, legends of drowned lands echo the flooding of low plains as the ice melted. These connections do not prove events directly, but they suggest that memory can stretch across millennia if carefully carried.
Now let us try a gentle thought experiment. Step 1. Imagine a community living by a bay, the shoreline their home, their stories tied to its shape. Step 2. Over generations, the sea rises, covering the bay, taking fields and paths. The people move inland, but they carry the story of what was lost, repeating it so children will know. Step 3. Centuries later, long after the details are blurred, the story remains, and when compared with cores of sediment and drowned landscapes, it resonates with evidence of real change. Before moving further, let us pause on the role of story itself. Unlike sediments or shells, which record passively, stories are chosen, shared, shaped. They tell us not only of what happened, but of what mattered. They preserve not only facts, but meaning. And meaning, too, is part of the archive of coasts, showing how humans experienced and remembered the breathing of the sea. The careful conclusion is that oral traditions may act as long, fragile bridges between past and present. They are not precise records, but they are reminders. When read with caution, alongside geological and archaeological evidence, they extend our sense of time beyond the written word. If we let this thought settle, it brings a quiet recognition that the memory of drowned coastlines is carried not.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. Only in the earth, but also in human voices, echoing softly across generations, preserving the rhythm of seas in the form of story. What if the memory of drowned coastlines could also be traced through the language of ice itself? In glaciers and ice sheets, layer upon layer of frozen water accumulates, each year sealing away a faint record of the world at that time. Dust from deserts, salt from oceans, tiny bubbles of ancient air. Together, they form an archive as fragile as glass, yet more enduring than most human records. When ice melts, seas rise, and when seas rise, coastlines change. By reading the layers of ice, we catch indirect glimpses of when and how those shifts occurred. To place this in context, let us imagine scales of tens of thousands of years. Ice cores drilled from Greenland or Antarctica extend back through multiple glacial cycles. Each thin layer of ice is like a page in a diary, marking cold years and warm years, wet times and dry. Trapped within are gases that tell us the composition of the atmosphere, particles that show volcanic eruptions, and isotopes that signal temperature. These records allow us to link the breathing of ice with the breathing of seas, and, by extension, the drowning and uncovering of coasts. The mechanism is delicate but clear. When snow falls, it carries with it traces of the environment. Over time, it compacts into ice, sealing in those traces. Oxygen isotopes within the water molecules shift depending on whether the climate was warm or cold, providing a thermometer written in chemistry. The amount of certain gases, such as carbon dioxide or methane, reveals how the atmosphere shifted alongside. Even dust layers mark how winds carried soil from exposed plains, many of which are now beneath the sea. By studying these signals, we begin to sense when coastlines changed, even if we cannot map them directly. Yet we must pause to note limitations.
Ice cores are drawn from specific regions, mostly polar. They tell us about global patterns, but not about the exact outline of a drowned valley or bay. Their signals are broad, not local. Absence of a clear marker in ice does not mean a change did not happen on a particular coast. It only means that the global rhythm was quieter there. We read these records with care, piecing them together with sediments, fossils, and archaeology. Still, the language of ice adds depth. Dust peaks in cores often align with periods of low sea level, when vast plains were exposed and winds carried more material. Shifts in carbon dioxide correspond with warming, ice melt, and sea rise. Even the tiny trapped bubbles of ancient air whisper of atmospheres that shaped coasts very different from ours. These signals connect the land, the sea, and the sky in one archive. Now let us try a gentle thought experiment. Step 1. Picture a cold world where ice spreads across continents, locking water away. Seas fall, coastlines stretch far outward, and plains appear. Step 2. Centuries pass, the climate warms, ice begins to melt, and seas rise. Valleys flood, coasts retreat, communities move inland. Step 3. Long after, scientists drill into polar ice, pulling out cores that contain the chemical signals of that warming. By comparing these signals with drowned landscapes, the rhythm becomes visible. Ice melting, seas breathing, coasts shifting. Before we move further, let us pause on how remarkable this is. Ice, though fragile, preserves memory across immense spans of time. Unlike stories that change, unlike shells that dissolve, the bubbles in ice are direct samples of ancient air. In them, we hear the atmosphere as it was, unchanged, waiting. And through them, we understand the connection between ice, sea, and shore. The careful conclusion is that ice cores, while distant from coastlines themselves, are among the most powerful archives we hold. They tell us when seas rose, when lands were lost, when coasts redrew their outlines. They do not give us detail of each drowned valley, but they give us the rhythm that underlies them all. If we let this thought
rest, it reminds us that the story of coasts, peaceful, quiet, and relaxing. It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences, to create a comfortable and peaceful atmosphere. What if the traces of drowned coastlines are not found only in nature's own layers, but also in the ruins left by people who once lived at the edges of the sea? Across the world, there are hints of stone walls, submerged paths, and patterns of settlement now hidden beneath the waves. These are not always grand monuments. Often they are simple structures, the remains of daily life. Yet together they suggest that the rising sea not only reshaped land, but also erased human places, turning villages into memories. To set this in context, we must imagine scales of thousands of years when human communities were small, scattered, and deeply tied to their local environments. Coasts were attractive places to live, providing food, transport, and fertile ground. But when the sea advanced, these same places became vulnerable. Some communities adapted and moved, while others left behind traces now drowned. Today, divers, sonar surveys, and accidental finds bring pieces of these landscapes back into view.
The mechanism of preservation is both fragile and surprising. In some places, stone walls or foundations remain intact, heavy enough to resist currents. In others, wooden posts are preserved in anaerobic mud, sealed away from decay. Pottery shards, tools, and hearths are sometimes found in layers that were once dry land. These materials do not survive everywhere, and where they do, interpretation is delicate. Now let us pause and acknowledge limits. A line of stones may not be a wall, but a natural formation. A pattern of holes may not be posts, but erosion. Absence of structures does not mean people never lived there. Preservation is uneven. Discovery is partial. We must be cautious, distinguishing what is human from what is geological, and recognizing the gaps in the record. Still, there is a language in these finds. In the Mediterranean, submerged roads and harbor works suggest organized settlements before sea levels rose. In the North Sea, wooden platforms and tools found offshore hint at dwellings on what is now seabed. In parts of Asia, drowned temples and towns lie where rivers once met the ocean. These do not give us a full map, but they whisper of the continuity of human presence at shifting coasts. Now we may try a thought experiment. Step 1. Imagine a small village on a plain near the shore. Homes built from wood and stone, fields spreading around them. Step 2. Over centuries, the sea rises slowly, flooding fields, eroding banks, forcing families to move. The village is abandoned, its posts sinking into mud, its stones scattered by waves. Step 3. Long after, archaeologists recover fragments, potsherds, firestones, post holes, enough to piece together the outline of a life that once was. From these traces, the drowned village is remembered, even if not fully known. Before we move further, let us pause on the meaning of these remains. They do not speak only of loss. They show resilience, the ability of communities to adapt, to move, to carry culture inland. What was left behind is a shadow, but the people themselves continued. The sea erased the place, but not the traditions carried forward by those who left. The careful conclusion is that drowned structures and settlements are rare but powerful markers. They remind us that coasts have always been dynamic, that our habit of living close to the sea is both opportunity and risk. They do not provide certainty, but they offer quiet testimony that the line between land and sea has never been fixed, and that human life has always adjusted to its ebb and flow. If we let this thought settle, it gives us a calm awareness that beneath the surface of today's oceans lie not only landscapes of nature, but also the faint outlines of human homes, silent witnesses to the long dialogue between people and the moving edge of the sea.
What if the story of drowned coastlines is also told in the shifting of plants and animals, quiet migrations that mirror the rising of the sea? When land was exposed, grassland stretched far outward, forests grew where now there are waves, and animals followed the changing edge. As waters advanced, those ecosystems retreated, leaving behind pollen, seeds, and bones as subtle markers of their passage. In this way, the memory of vanished coasts lives not only in rocks and sediments, but in the traces of living things adapting step by step. To place this in context, let us imagine the scale of recent decades.
For most of human history, knowledge of the seafloor was shallow, limited to what fishermen dredged up or divers glimpsed in clear water. Only in the last century have we begun to map large areas systematically. Now, through remote sensing, the drowned valleys, riverbeds, and plains once lost are revealed with surprising clarity. The mechanisms vary, but all rely on signals. Sonar sends out sound waves that bounce off the seabed, their return time showing depth and shape. Satellites measure tiny differences in sea surface height, caused by the pull of submerged mountains or valleys. Cores bring up columns of sediment, each layer carrying chemical and biological traces of past environments. These tools do not give us photographs of the past, but they allow us to reconstruct it step by careful step. Yet we must pause and note the limits. Instruments can mislead. Sonar shadows may create illusions of walls or ridges. Satellite readings can be blurred by waves and currents. Cores tell us only of one narrow spot, not the whole landscape. The absence of clear data in one place does not mean the landscape was absent. It may only mean our tools could not capture it. Knowledge grows, but it remains incomplete. Still, the language of technology provides valuable clues. High-resolution sonar has revealed submerged river systems beneath the North Sea, winding much like modern rivers across plains now drummed. Satellite data have hinted at hidden ridges and plateaus, once above sea level, now guiding ocean currents. Cores have shown peat layers far offshore, evidence of forests that grew on land later covered by rising water. These fragments, gathered from different tools, fit together into a mosaic of drowned worlds. Let us try a gentle thought experiment. Step 1. Imagine a broad coastal plain long ago, with rivers, forests, and human camps scattered along its length. Step 2. The sea rises, covering the plain, hiding it beneath layers of silt and waves. Step 3. Many centuries later, sonar scans reveal the outline of the old rivers. Cores pull up peat from ancient soil. Satellites detect subtle ridges. Piece by piece, the plain is remembered, not in full, but enough to sense its form and scale. Now we may pause on a subtle point. Technology not only recovers the past, but also shapes how we imagine it. We do not see the drowned plain directly. We see data, transformed into maps, models, and reconstructions. These are interpretations, not absolute truths. They are guides, reminding us of what may have been, while still leaving space for uncertainty. The careful conclusion is that instruments extend our reach, but do not erase the unknown. They let us glimpse drowned landscapes through echoes, signals, and cores, but always in fragments. If we let this thought rest, it reminds us that the story of ancient coastlines is not only about what nature preserved, but also about how gently we learn to read it, using tools that turn silence into patterns, and patterns into memory.
Now let us imagine scales of thousands of years. During the coldest times, when much water was locked in ice, coastlines extended far beyond today's limits. Herds of grazing animals roamed plains now under the sea, followed by predators and people alike. With warming, habitats shrank, forests shifted inland, and wetlands drowned. These movements were gradual but profound, a long retreat that reshaped entire regions. The mechanism is simple to grasp. Plants release pollen, tiny grains carried by wind and water. These grains settle into mud and remain preserved for millennia, their shapes distinctive enough to identify the species. Animals leave bones, teeth, and sometimes footprints, buried in sediments that later become submerged. By studying these remains, we trace the comings and goings of ecosystems, seeing how coastlines guided the living world. Yet we must pause to admit limits. Pollen can travel far, carried from distant places, so its presence does not always mean local growth. Bones may be washed into layers long after the creature died. Preservation favors some environments and erases others. The absence of a signal does not mean absence of life. It may simply mean the archive has gaps. We move carefully, interpreting these records as partial, always aware of uncertainty. Still, the language of biological traces is rich. Layers of peat buried offshore tell us that forests once grew on land now beneath water. Concentrations of salt-tolerant plants mark the slow advance of the sea. Fossils of large animals found in drowned valleys hint at grazing plains that stretched far into what is now ocean. Even the distribution of shellfish and corals reflect past coastlines, as their habitats shifted with depth and salinity. Together, these fragments draw a picture of ecosystems ebbing and flowing with the sea. Now, let us try a gentle thought experiment. Step 1. Imagine a wide, grassy plain where rivers cross toward the sea. Herds of animals graze, plants spread pollen into the wind, and people hunt and gather along the edge. Step 2. Centuries pass, the climate warms, ice melts, and the sea creeps inland. The plain shrinks, the herds retreat, forests move higher, leaving behind seeds and bones buried in new layers of mud. Step 3. Long after, researchers pull up cores from the seabed, finding pollen that tells of forests, bones that speak of animals, and shells that record the changing shore. In these signals, the plain is remembered, though it has been gone for millennia. Before we move further, we may pause to reflect on what these shifts reveal. They remind us that coastlines are not only lines on a map, but boundaries of life. As they moved, they carried with them entire worlds of plants, animals, and human activity. What was drowned is not only land, but also habitats, food sources, and ways of living. The careful conclusion is that the record of drowned coastlines includes the quiet testimony of biology. Pollen grains, bones, seeds, and shells together tell of vanished ecosystems layered gently in mud and sand. They are not precise maps, but they whisper of forests once drowned, plains once grazed, wetlands once alive with birds. If we let this thought rest, it reminds us that the edge of the sea is always alive, always moving, and that its memory is written in both the earth and the living things that once walked upon it.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences to create a comfortable and peaceful atmosphere. Vast glaciers expand, locking water into ice and exposing wide continental shelves. During warm phases, the glaciers melt, seas rise, and the drowned landscapes return to silence. The coastlines we know today are only one snapshot in this long alteration. The mechanism is tied to what scientists call orbital cycles. Earth's path around the sun is not fixed. It shifts slightly in shape, in tilt, and in timing. These small changes alter how much sunlight reaches different parts of the planet, setting off cascades of climate responses. Ice sheets grow or retreat, seas rise or fall, ecosystems adapt or vanish. Though the changes are slow, their consequences are vast. We should pause here and note our limits. We cannot predict every detail of how coastlines responded in each cycle. Sediment cores and isotope data show broad patterns, but not precise shorelines. Some cycles are clearer than others, and gaps remain. Absence of record does not mean absence of change. It means that time has erased or blurred the signals. Our knowledge is partial, a careful reconstruction rather than a complete picture. Still, the language of cycles leaves distinct traces. Oxygen isotopes in shells tell us when ice volumes were greater or lesser, marking the waxing and waning of glaciers. Coral terraces lifted above current seas show past high stands of water. Buried river valleys offshore reveal times when land was exposed. Together, these fragments allow us to see the pulse of climate, its slow beat marking the advance and retreat of coasts. Now let us try a gentle thought experiment. Step 1. Imagine a world in deep cold. Ice covering vast regions, seas lower by more than 100 meters. Plains extend far outward, rivers flow across what is now ocean floor, and coasts lie far beyond today's maps. Step 2. Over thousands of years, warmth returns. Ice melts, seas rise, plains vanish beneath waves, and coastlines retreat landward. Step 3. Long after, we stand in the present, reading isotope curves, coral terraces, and drowned valleys, reconstructing the rhythm of those shifts. The picture is incomplete, but the pattern is clear. The sea has never been still. Before moving further, we may pause to reflect on what this means. The coastlines we inhabit now are not fixed boundaries, but temporary ones. They are part of an ongoing cycle, one phase in a rhythm that will continue long after us. Human time is brief compared to these scales, yet we find ourselves shaped by them, our histories entangled with the sea's slow breathing. The careful conclusion is that the memory of drowned coastlines belongs not only to isolated events, but to the great cycles of climate itself. Each rise and fall of the ocean is part of a larger rhythm, inscribed in ice, coral, and sediment. If we let this thought rest, it reminds us gently that permanence is an illusion, and that the edge of the sea, though it feels stable in our lives, has always been a line drawn by a moving hand. What if the story of drowned coastlines is not an ending at all, but an open thread, still unfolding, still being written by seas that continue to move? The landscapes we trace through ice, sediments, and ruins are not simply relics of the past. They are reminders that change is ongoing. The ocean has always advanced and retreated, erasing some places and creating others. What we inherit is only a momentary outline, drawn across a canvas that never stays still. To set this in context, let us widen our view beyond thousands of years, to the long horizon of Earth's history. Across deep time, seas have flooded continents and withdrawn again, leaving vast inland seas, coral plains, and desert scars.
The coasts of today are young, temporary sketches compared to those older cycles. What vanished with the last great melt is only part of this larger pattern, a single verse in a longer rhythm. Understanding this gives us calm perspective. The mechanism of these shifts remains the same. Ice melts or grows, water expands or contracts, tectonic plates rise or sink. Each process adds its mark to the shoreline.
It's important to keep the tone interesting and engaging, as if you're telling a story about the Middle Ages. Speak slowly, with soft pauses between sentences to create a comfortable and peaceful atmosphere. On shorter scales, storms and currents rearrange beaches. On longer ones, climates and ice sheets redraw entire continents. Coasts are not borders etched in stone, but moving boundaries, guided by forces both slow and unstoppable. Yet we must pause to acknowledge what we do not know. The exact shape of drowned valleys is often blurred. The timing of future changes is uncertain. Even the records we hold in sediments and isotopes are incomplete, with gaps where memory has been erased. Absence of evidence is not absence of history. It is only silence in the archive. This humility is part of how we listen to the sea's story. Still, the language of traces continues to guide us. Cores tell of buried forests. Ice layers record ancient air. Sonar maps hidden plains. Together they form a mosaic that grows clearer each decade. By weaving them carefully, we see not only what was lost, but also how the earth itself remembers. It is a memory written not in words, but in layers, bubbles, and grains, patient in its persistence. Let us try a final thought experiment. Step 1. Imagine standing on a present-day coast, watching waves touch a line we call the shore. Step 2. Stretch the view forward, centuries passing, seas creeping higher, the line retreating inland. Towns, forests, and fields give way to salt water. Step 3. Carry the view even further, to a time when our traces too may lie beneath the sea, leaving behind only fragments, stone, glass, metal, that future eyes may interpret as we interpret those before us. The thought is not fearful, but grounding. Now we may pause, before closing, to reflect on what all these layers tell us. They do not point to a final conclusion, but to a truth of continuity. The coasts we know are both fleeting and eternal. Fleeting in their outlines, eternal in their rhythm of change. Our role is not to halt this motion, but to understand it, to live with awareness that the line between land and sea is alive, shifting in its own time. The careful conclusion is that the story of drowned coastlines is also the story of time itself, of the Earth's restless balance between ice and ocean. What has been lost is not gone completely. It is remembered in signals that endure, in the quiet testimonies of mud, coral, and stone. If we let this thought rest, it offers us calm perspective. We are part of a larger rhythm, one that began long before us and will continue long after. And if this gentle pace and voice have carried us this far, then perhaps we already know how to continue, by returning, when we wish, to follow the tide of memory once more.